Good morning. Sivner? Hey, Dastis, good morning. How are you doing today? Yeah, pretty good here. Sivner, your daily status reports are always so the standard is very low. That's good. You know, just barely above ground, still breathing. It's very it's a low bar, and I suppose that makes it easier to end up satisfied, huh? Okay, how's the audio level? We're gonna get started. We got a little bit of Mozart right now. All right, well, let's go ahead and get started then. Okay. Do you guys want to do a quick review of the Caesar cipher as written, like a quicker version of what we did yesterday before we look at the homework, which are both assignments that are related to modifying it? Okay, yeah, let's do that. Okay, so also Rabseth posted this link in the classroom. I don't know if you saw it, but it's his notes walking through. If you want something else to look at, this is linked in the classroom chat. You can find that. Okay, let's look at Caesar. Let's see. Okay. Now, we modified this slightly. The only thing we did here was change in the mapmaker arm, we replaced this line with this long form line. So noting that the buck before the parentheses, this is just a regular form of send-tis buck. So we've replaced that for readability. Hopefully that is a little bit more readable. Otherwise, I believe we're looking here at our vanilla Caesar cipher code. Okay, so when we are trying to parse some new code, the first thing we'll want to do is get a basic understanding of what's happening at the highest level. So what are the code blocks? So the very first thing we have, ignoring zapcol, is just turning on debugging stack traces. So we know how to recognize our bardtis. It makes a gate. This is a gate that takes a tape and a step. So we've seen how to use this. Agent Dolphin, that was the name of one of our random wanderers from yesterday. So our generator is taking a tape, which is a list of characters, and a number, which is how many characters we will shift our cipher key. Tisgal means evaluate the following expression, which is lines 4 through 6. Taking the next expression as the subject, which means lines 8 through 58. So that's the highest level is gate, Tisgal, which is two expressions inverted. And that just means evaluate from here down first. Use that as a subject to evaluate this. So the effect is that in the main arm, the buck arm here of our gate, we have access to all of the arms that are created below in the core. Okay, tis.message, cast message. Tis.dot is modifying an arm of the subject, or a leg of the subject. Here it's a leg. Message is just a piece of data. So we're replacing message with cast message. Cast is the standard library function giving us an all lowercase version of a tape. So all we're doing is getting rid of uppercase characters. Okay, then we're creating a cell of the result of shifting our message by the given number of steps, and the result of shifting it the other way. So if we had already ciphered text, we would look in the unshift portion of our output. So we're shifting agent dolphin by 4. If we were to shift this eCare da 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 da, I can't do that, of course. Okay. Oh wait, what did I do? Oh, I didn't copy it. Okay, we get our agent dolphin back. So that's the purpose of having the 2 outputs. The idea is this one is supposed to be ciphering our message and producing ciphertext. The second one should be producing the clear text if we had given it ciphertext. Okay, next we need to look at which arms are called in this little block of code. So we see 2, shift and unshift. We pointed out yesterday that these are virtually identical, and in better written code, or maybe not, let's say in code which was intended to be, well, we can say better written. These would be commonized in some way. So the only difference between the 2 at all is this one, when it operates on the message, uses the map that would be generated by encoder, and this one uses the map that would be generated by decoder. So we can, for the purposes of what we're doing right now, ignore these. In fact, let's see if I break something. We should be able to do this. Get rid of that. So we're not calling that unshift, and we've uncommented out both of those arms. Okay, and so it works. Now it only gives us 1 output. So let's look at it that way. I just want to get rid of a little bit of code to save us some space. I did that time, Sivner. I did. I've been thinking of you. I still will tab up 1 or 2 times usually first before giving up and using reverse search, but oh well, what can one say? Guilty as charged. Okay, so this is just for the sake of being a little bit easier to walk through the code that we've removed those 2 arms. Okay. And we've noted that they work exactly the same as shift and encoder, just with the opposite order. Okay, so we see that right now we're producing only 1 output, so we give it the alphabet shift by 4, and we see the first 4 characters are shifted to the end, since we're just rotating each one by 4 characters. Okay, now with those 2 arms out, this will be a little bit more linear. Okay, so shift is saying operate on the message using this map. the map that we'll generate in the encoder arm. Okay, so operate this arm here. This is the actual arm which is going to pick characters, take characters and replace them. So this takes a tape and a map, produces a tape, and it just uses turn to go one by one through each character in the tape and replace and replace it with the results of looking up in our map. Okay, before we can do this operation though, we need a map. So that's where we use the encoder arm. So again, this command here, or this function, let's say expression, is saying operate on our message. That's just our input tape. So call operator using our message and the result of this expression, which we know from looking at what operate takes that this must be a map. The other way we can see that is looking at encoder. Encoder takes a number of steps and produces a map. Okay, so this is operate, tape, map. So the first thing, it's easy to see how operate pulls the characters out of the map using turn. Let's look at how encoder will create the map. Okay. We have a gate that takes a number of steps. We know that we want to produce a map. Okay, we have our value tape will be what? Our value tape will be the tape that we'll be replacing with. So one moment. Yeah, it was. This time we're not getting rid of it though, so so sue me. Well, don't sue me though. I'll be okay. Okay, so we have our key tape, value tape. You can't see my screen. Take the test card down. What? You still can't see my screen? Okay. I might have, when I tried to hit the hotkey to switch, it didn't switch. Okay, so just to look at what we have here. So our key tape, this will be the input. This would be like A, B, C. And our value tape, let's say, for shifting by 1. Now, let's just assume that's obvious. Okay, so these aren't the exact names that we're using, and they're a little bit different in each arm, but that's what we mean. This is our value tape. So, okay, encoder. So to create our value tape, we use a rotation arm. We give it our input tape. This key tape actually we're calling alpha. Okay. So our value tape, we're creating this tape by our rotation arm, which we give alpha in steps. So we need to look at the rotation arm. Rotation, we're giving it alpha and we're giving it steps. So just like our main generator, we're giving it a tape and a number of steps. Rotation, this is a fun arm. Isn't it? So let's look at what some things we have in our subject. Wow. Quite a bit, don't we? Four. Can't even get to the bottom of it. So, okay, let's just... Alright. Alpha. Alright, so we're looking at trim. Trim 5 alpha. Produces a cell of 2 tapes. The first one is the first n characters of the tape, where n is our first input, and the second tape is the last length minus n characters. Okay, so this is nice because it's not only concatenating the tape at a certain point, it's actually splitting it and creating 2 tapes. And they already have faces P and Q. So the way this works is, if we pin that to our subject with tis less, like so, then we can just address P and Q directly because they're already in our subject. And we get a cell of P and Q. So if we just do this and ask for P, we'll get it. We just do this and ask for Q. So tis less is pinning a value, pinning a noun to the subject. It doesn't assign any face to it, but since the product of trim comes with faces nested inside it, then that's already available to us. So then it's easy enough, I think, to see what we're doing in here with weld. We're saying we know that the first half, we're producing a cell with the first half as a tape named P and the second half as a tape named Q. We can just weld them back together in opposite order, weld Q and P, and we get our reversed tape, or rotated tape, effectively. So we have the first 5 characters at the end, and then the balance of the tape at the beginning. So this arm is just rotating our input tape by the number of steps that we've given it in order to make our key tape, or our value tape, I'm sorry. Okay, and again, a couple of other things. We're adding length to our subject, which we're just measuring or checking with lent my alphabet. This line is not necessary. If we didn't want to do it that way, we could just do it like this without this. That's effectively the same. But the purpose here is to make code as readable as possible, and sometimes that makes it a little bit more verbose in the process. Okay, so rotation produces our tape, our permuted value tape. Now, in my opinion, we should get rid of this space adder arm. It's a little bit, for one thing, it's a little bit confusing to me anyways, why we are like, we know encoder, we want it to, this needs to produce our tape. This is the main encoder, main arm that produces our tape. Okay, fine. So it calls space adder to create our tape. Well, that's a little bit odd to me. Okay, so let's talk about why and what's it doing. Mapmaker is making our encryption map from input characters to output characters. So our map is going to look something like this. I'm just going to use curly brackets. Yes, you're exactly right, Sivner. So it's going to have cells of A and B, and a cell of B and C, and then a cell of space and space. So correct. We first are making our map, which would have all of these pairs. After we do that, we're adding a space to it. Which is fine. As far as the way to do things, it's totally fine. Except since these take the same exact sample spec, and they both produce a map, it's pretty clear that we could have just put this here into this arm. And the way we would do that is first build up the chart. We'll look at it more closely, but in this portion here, we're building up the chart one character at a time, recursing through our input tape. When we get to the point where our tapes are null, we simply produce our chart. But we could just do this instead. We could take this. So let's get rid of this arm. And then here, let's just put a note. Okay, well, I better fix it. Actually, it wasn't going to in that case, actually, because I didn't change out. Now I need to, in our encoder, instead of asking for space header, I need ask for mapmaker. But you know, I agree with you, Sivner. I never expect it to the first time, and when it does, then I'm like, wow, pretty good at this, huh? Um, okay, and it did. So, okay, so all we've done there is we've removed this space adder arm, and we've put it here. So after you build the chart, you add a space. Yeah, well, I appreciate that. And really, it is funny because not so long ago, I mean, I still always expect it to fail the first time. You know, it's just kind of a learned thing. But more often than not, now it doesn't, and that's a nice feeling. Um, once you kind of just get a hang for what your code's actually doing and what it's looking for at each place. So should we be editing it like this or the way it's written? It doesn't really matter. I think I might actually submit a pull request to change it this way in the docs. I mean, maybe the only concern then is you get to this point and it's like, you know, what is this doing? But I think that's clear enough. Let's go back to how it was. Okay. Look at me using reverse search to get my commit line. Okay. But that's what we're doing. It's just, we're calling it in the opposite order. We're doing space adder. First we're making the map, then we're doing space adder. Okay. Give me 1 minute. Sivner, why don't you look at this and see if you can walk us through how this map maker is building the map. You have a minute or so, so you can be as verbose as you'd like. Okay. We start off with a gate that takes 2 inputs, a tape and tape, 2 tapes, you're correct. And we're casting our output to a map from pat T to pat T. Okay, correct. Error check will crash if the tapes are different lengths. Yes, that's here. So the sig bar is just produce an error message, and then we give it crash. Then our what call checks whether we've got whether either of the tapes is null. Yep, yeah, correct. Except I don't know if you remember yesterday when I said this, that since they're the same length, we could just check one or the other. I tried doing it that way, where we only checked one, and the problem was then we had the problem with that you can't look at I dot to find the head if we didn't check each of them being null. So I was a little bit. I assumed that would work yesterday, but we checked it and it didn't. So, but right. So if either of them is null, we just produce the chart as is with a space tagged onto the end, and then the recursion. Oh yeah, there is a child now. She hasn't been with us in a while for our class, but she didn't really want to sleep, so. We're going to solve the problem with Cheerios. Okay, so we're looking at what is the recursion doing? You know, that's a possibility. It's definitely something that could happen. And plus, I think even at double the cost, it would still be a reasonable price. So we'll think about that. I don't even know how to do such a thing. Joy. Alright. That's the best we're going to get for right now. Maybe we will start doing video. I got no problem with it. How do I? Alright, Joy, let's give them what they want to see. What do you want? You want Cheerios. Alright, back to our regularly scheduled programming. I'll think about that. It's okay, there we go. What have I done? Oh. Where were we? We're looking at what this recursion is doing. So, the first thing to note before we get into that is that we're starting off by bunting chart here as a map of pat T to pat T. So, bunt we also know is just the tar operator like this in a regular form. So if we just do tar map pat T, we should get what? What am I doing wrong there? Yeah, I really don't know. I mean, this is one of those things where it's like, it just makes one wonder. Alright, well, without quibbling over it, so here when we miss something, we'll go look at our cheat sheet. We're about to abandon ship. Alright, yeah, we're abandoning ship. Well, anyways, it's null. The bunt value of map pat t is null. Why I can't do this right now, I don't really know. I have to think about it later. So, but we can demonstrate it this way. Why does this not want to work? Why can't I? Okay, let's try. I mean, this isn't going to work either, but. Right. Okay, let's confirm that our generator still works, just before we ignore that, pretend we didn't discover it and move on. Okay. I know that we were doing that even yesterday with that same syntax, and that is correct. Well, and obviously it's correct here, so but regardless, it is working with in our code, so that's good enough for right now, because what we need to look at is chart here. So when we are recursing, we're saying recurse, but replace chart with this. So remember, the first time we go through, so if we have iteration 0, chart equals null. Whoa. Yes, it is correct. So chat is null. What do we have? What are we calling these? Key position and value result. Let's just call them key tape. No, just to call it key and value. Okay, so let's say key is ABC. Value is CDE. Iteration 1, so after we call it one time, we'll replace chart, which starts out as null, with put by chart, so insert into a chart the head of key position and the head of value. So now chart will become using, so actually we'll just use map this curly brackets to demonstrate that we're talking about a map. So here now chart is going to have one item, which is going to be a cell of A and C. And then key, what's key going to be? Key is going to be the tail of our key tape, which is what? It's everything but the head. So the key would become BC, value, thank you, dash this value will become DE. Okay, let's just make all this a smaller size so we can fit more of it. Oh, now our tabs are all screwed up, aren't they? Okay, let's just go through this quickly. Let's take this. So iteration 2 and 3. So for 2, chart will be B and D. And we strip B and D from these. Iteration 3. We will have added C and E. Our tapes will be null. So we're going to do these are the values that like at the start of iteration 0. So the first time we operate, these are the values. So these are the change values for the start of iteration 1. These are the change values for the start of iteration 2. These are for the start of iteration 3. Now, when we get to iteration 3, we'll have the null tapes here, so we're not going to iterate again. So I'll just put here exit condition, both tapes null. And then we will I did leave this. I thought I got rid of this space adder right here. Because I put the space adder back. Are we still using it? We're still using it. So our map actually probably has, so if we put right here, well, where would we want to put this? So this is producing our modified tape. Map maker space adder. I think it might be the case that our map has 2 spaces right now. Because we really don't need this, since we put our space adding arm back in. Okay, both tapes are null, and that's good. That's all we need for this. So that's how we are walking through the recursion. Okay, now, that all kind of waterfalls back upward. Well, let's see. can't demonstrate that too easily right now because, well, what we could do is, let me make sure I didn't just break it before I do something that will probably break it. Okay. Well, if we give it a tape that's all the same character, that would be, oh no, it wouldn't. I'm sorry. No, it wouldn't. Because our map still is only using. Well, you know, the thing is, if I could bunt a map here for you, we could just check that. My brain, somewhere between my keyboard and my ship that's broken. But why? Well, we can just do this. That's not working either. So I really have done something. So oops. All right. Let's do this. So how if it's like I've broken something. Just do our little clear shutdown command. So, okay. I don't know what I had done exactly there. But I think I know what I had done roughly at least, which is I had put something in my subject, maybe using, I don't know, which has one of the names of one of the common standard library bits, which is used in math. Okay, well, let's just do, I mean, like, maybe I shouldn't even call this map, actually, just in case, just to, it would be interesting to know what I had done there, but, so, we have a map now, which is empty. Well, something was in my subject that, like, if we look up hoon.hoon on GitHub, well, no. You know what? Google's the worst. Like, half the time when I search just like that, it gives me exactly what I'm looking for, and other times I have to navigate all the way here. Like maybe I had either key or value in my subject. So since when I was, like it shouldn't be this A because that's defined in the sample here. I don't know. Something was screwing up the name resolution. Okay, so now let's try inserting in here, put by chart, put by A map, and let's just give it like 1, 2. Okay, so that works. Okay, now we'll do the same thing. And we're gonna add 1, 2 again, and now we're gonna look at CMap. So, no, it just doesn't do anything. So, although maps, have the shape of a binary tree, they're like sets in that they're just sets of values which are, for all intents and purposes, not ordered. So I don't know technically how that works, if it's random ordering or what, but anyways, if you try to insert the same value into the map again, it doesn't duplicate it. Now, what if you had tried to put the same key with a different value? So again, it recognizes that it's the same key and overwrites it. It doesn't include both. Now, on the other hand, if you wanted to have a different key going to the same value, that would be allowed. That would just give you, the key of 1 and 2 both are going to produce 2. So that's allowed. But any collisions in key, the new one will just replace the old one. Okay. So we used up most all of our time on review, so let's look at the homework briefly, and we'll go through it more in depth tomorrow. So for today, we'll look at number 3. Yes, it overwrites. Okay. Actually, let's look at it in our assignment, because we did change the verbiage slightly and the requirements slightly from what's given in the docs. Okay, so exercise 2, we have rewritten here. Extend the example generator to allow for use of characters other than A to Z, so like numbers or punctuation. And then we have as a bonus for intrepid students, make it shift the new characters independently of the alpha characters by character set, such that punctuation is only encoded as other punctuation and numbers are only encoded as other numbers. So that's like the stretch goal. The first task is just to make it use other characters. Exercise 3 is to build a gate that can take a Caesar shifted tape and produce all possible unshifted tapes. Okay. So lesson 3 is pretty trivial. We could take a quick look at that right now. So here I already have it just producing one thing, right? So we're producing the result of shifting by message and steps. So now we don't need steps anymore. This is for lesson 3. So we'll just put a 0 in there. Oops. Oop. What? What is going on? See, this is why It's because I nuked my dojo. That's why I couldn't reverse search. Oops, that's not a hood command. The generator. All right. Okay, so right now, like I said, we're going to go through this quickly just so we have done some homework help today, and then tomorrow we'll look at it again, and we'll look at number 2, which is a little bit bigger. But okay, message equals tape. We have gotten rid of the key value from our sample because we're just going to produce a copy with all of the keys from 1 through 26, so we don't need to take one anymore. We're still going to cast our message, and then right now we're producing our message shifted by 0. We can see if we change this. Yeah, that worked. Okay, so what we need to do is produce, so one way we could do this is like this. Yeah, that should be fine. Okay, so here we have our input tape, and then shifted 1 character, shifted 2, 3, 4, and 5 characters. So we could just do that 26 times, right? Let's not do that though. Let's do this with recursion. And we're just going to hard code the stop as 26. So let's do, actually no, I was just demonstrating for the fam here. Okay, so let's call this count equals 0 and stop equals 26. Let's do counting as 1. Okay, make a trap. Now what do we want to do? What do we want to do here? I want to create a cell of shift message count and the result of iterating with count equal to count plus count plus count. Now this will give us an infinite loop, so we do want to make sure that we add an exit condition, right? So we'll make these produce a list, and first we'll say what call tis count stop, and if it is, then we just produce null, and if it's not, then we produce the rest of our thing, and then we can cast our result to a tape. See, I'm glad that you were able to see that, Sivner, because it's good, it's good to know that we're all human. Okay, good, nice. Yeah, see, we'll get even more of this. Let's say now you'll be even luckier if we run into quite a few more of these. Okay, so where are we running into? Mint nice from 9, 1 to 10, 18. Okay, probably we did too many things at once anyways there. Let's get rid of this. And so the first thing we're doing is we're checking. Okay, we're checking if count and stop are equal. If they are, we're producing null. If they're not, we're producing a cell of shift message count and the result of recursion with count incremented. That all seems sane to me. Oh, okay. So it was my cast that was breaking it. So I put a cast here, right after the, right here I'd put a cast tape. And that gave me a midnight. So, in what way? This is so weird. Like, why would it just decide to put these three on the same line? Oh, I don't. Okay, it's because I want it to be a list of tapes. Not a tape. Alright, there we go. Except there's no way that's 26, right? Oh, that was strange. What is going on? Oh. I guess that is. Oh, it looks like so many fewer without all these brackets. Okay, so now we can give it some cryptic text. And we run it, and then we look and we say, okay, do any of these? Aha, hello. That was our, all right, here's what we're gonna do. All right. There we go. Let's see what... Okay, Dastus, thank you. Let's see what our cryptic text says. We'll run it through our cipher and just have a look for something intelligible. Let's see if there is anything intelligible. Ah, here we go. Thank you for joining us today, class. All right, so this is how you could do lesson 3. The one thing we did get caught up on here was trying to cast to a tape, when obviously this is not what we were producing, was not a tape, it was a list of tapes. With that out of the way, this is a pretty straightforward task. So let's save this as... Okay. Alright, that will be all for today. We will continue tomorrow, where we will look at assignment number 2, or exercise 2. Oh, God bless you. Ugh.